So now that we've talked about how a function is defined, we can discuss our function notation, which you guys are probably familiar with. So this is our function notation. So we could see an equation, for example, like y equals 2x minus 5. We all know how to graph this linear equation. We could rewrite that same equation in function notation and say f of x equals 2x minus 5. So when I'm reading that, this is read as f of x. And one thing that I want you guys to remember is that y and f of x are interchangeable. So notice that we switched out y with f of x. Y equals f of x if you have a function. So any equation, any equation of a function that's written y equals, we could rewrite that as f of x equals. And in this form, remember that x is an input. So we're going to put in an x value into our function, and it's going to give us our output, our y value. So every time we put an x value into a function to evaluate that function at that x value, the result is a y value, and that tells us that that ordered pair is going to be a part of the graph if we were to graph that equation. So for number 6, we have g of x equals x cubed minus square root of x plus 5, and our instructions are to evaluate and simplify each function at the given values. So first we have g of 4. So anywhere there's an x in my function, I'm going to replace x with my input value of 4. I'm going to replace it with 4 in parentheses. So 4 in parentheses cubed minus the square root of 4. The square root's kind of acting like my parentheses there, plus 5. 4 cubed is 64. Minus square root of 4 is minus 2, plus 5. 64 minus 2 is 62, plus 5 gives me 67. So that's my answer. That's my result. Sometimes on a test, you guys want to impress me, which I love. That's fantastic. And some of you guys write this. So you say, okay, so g of x equals 67. That's not a true statement, what I just wrote out. That's not a true statement, so please don't write that. G of x does equal x cubed minus square root of x plus 5, but it doesn't always equal 67. It only equals 67 when I put in the input of 4. So this is a true statement, that g of 4 equals 67. That's a true statement that you could write. And you could also say that my graph, if I were to look at a graph of this function, now I know that the graph passes through the ordered pair 4, 67. 4 is the input, 67 is the output. So let's try this again with g of 0. So 0 cubed minus square root of 0 plus 5 equals 0 plus 5 equals 5. So I could say that g of 0 equals 5, and I know that the function passes through the ordered pair 0, 5 on its graph. Now in number 7, we're looking at a new function. H of x equals 2x over x squared minus 5. So h of negative 2 is 2 times negative 2 over negative 2 squared minus 5. And again, notice that I'm putting that negative 2 in parentheses, and that's especially important down here. So up top, 2 times negative 2 is negative 4. In the denominator, negative 2 in parentheses squared is positive 4. So make sure you get that positive 4 rather than a negative 4. And then I have my minus 5. So then negative 4 over 4 minus 5 is negative 4 over negative 1 equals positive 4. So this graph would pass through the ordered pair negative 2, 4. H of negative 2 equals 4. And h of 3 would equal 2 times 3 over 3 squared minus 5, which is 6 over 9 minus 5, which equals 6 over 4. And at this point, just pay attention to the formatting instructions. If they want a simplified fraction, then your final answer is 3 over 2.